Okay, dears. You can see from here we have another session, another section is talking about system of the equations. So we have a system of linear equation, but for what? Instead of two variables, we have several variables. When you say several variables, means that you have at least three and go on, 3, 4, and up to you. So here we are, you can see we have a linear system like that, x, y, z. So this is called a linear system. And that called also a linear system, but with triangle form. Why triangle form? You can see from here, we can write triangle. Later, in the 10.3, we change the system with a full to the triangle and we solve it. And we have many ways to solve it. So here we are solving triangular system of backspace or back substitution. You know, for example, if you have something like that, I think it's easy, you can solve it, right? Even it's a 3 variables, but x give z here is given, y plus 2z, so means that y equal to what? 6, 5, y equal to minus 1. You can see because a triangle, I can go to up, right? We can go to up. How about if I have an x and y? So I'll get what? If I have a 3 here, if I have a minus 1 here, of course, it's easy to find the value of x. Do you have any question? It's clear how we solve it? Dears, hello? It's clear? Shall I repeat it? No, good. So we have a system, let me do it quickly. We have a system, but with the 3 variables, x, y, z. And if is in that form is called triangular form, which don't need anything to do, just substitute it. For example, you have a z, now I got z. Then to get y, I'm going to put z here. I'll get 2, 6, 5. Y will be minus 1. I'm going to substitute this z in the second equation. Okay, so I'll get minus 1. Then I'm going to put the value or substitute the value of x and y, z and y. So here's 3 and here's minus 1. So I'm going to substitute that value to get the value of x. So I will get x. Understood? In that case, I'm going to write also x, and that will be my solution. You can see he substituted, got y, and substitute the first equation, x minus 2y minus z equal to what? 2, 1. So because y is minus 1, z is 3, I'll get x is what? X is 2. So 2 minus 1, 3 is my solution. And if you want to translate this in the geometry, in the space, what do you mean by that? What do you mean by this point? Of course 3D, but what do you mean? We have an intersection point like that. So what do you mean? In the second dimension, do 2D, we say intersection is what? This means that two lines, they intersect. Am I right? So how about in the 3D? No. Each equation here, dears, each equation here is a plane. Plane, like your copybook. This is the plane, that one is the plane. The whiteboard is the plane. So each one, the first equation is the equation of the first plane. The second one for the second plane. The third one for the third plane. So, like a copybook that you have. So when you say 3 planes, that one 1 and 2 and 3. So now 3 planes, you got here, 3 planes, 3 planes are intersect. There, والتحت هي T أول in quotation. So 3 planes are intersect. So how is the result? Result أكيد شيء درجة. Look at here. كوا وجبت أنا باشتري. I'm a 3 plane. That's what. You want to keep playing it. Daj to ci derece. Premier style you have to look at in one. Scene one. One what? No. intersect دو چی درجه right and left چی بینی اگر اکتیو کنم one line right بتوانی که برون چی بینی توسن I'm playing of the nation so you will see what one line if two lines intersect you see what one point right one point so if I have a one I have a line that's why it's called intersection between planes so here we are the translation of the intersection here is the plane. So it means that we have three planes. Look at here. Here's the point. Here's the point. Here's the lines. Understood? Understood here? So if we have two planes, we have a line. If I have three, we have like that and like that. So if they are one point, intersecting at one point, we have a single point. If they are intersect more than like a two planes as we saw together, one, two, and more points is called a line. If they are not point, it means that there is no equation or there is no solution for the system. Going back to the example to understand more. So I'm going to solve the first example for you. Kindly try it at home. So I'm going to solve these together. Yalla, listen to me. Listen to me. If you get that one, you can control this section again. So kindly be with me how to solve it. Later you can control it. So I'm going to write the examples. So we have x minus 2y plus 3z equal to 1, x plus 2y minus z equal to 13, 3x, 2y, 5z equal to 3. Now, here we are. We have what? We have two or three equations, right? 1, 2, 3, with three variables. So how we solve them? First of all, look at me at the beginning. I'm going to solve the first example with the second example. Then I'm going to get first example and second. I'll get example number 4. Then later I'm going to solve first example with the third example, and then I'll get equation number 5. Then later I'm going to solve these together. I'll get solution. That one in here we have a 10.1. We saw from 10.2 we are changing to the 10.1, and here's the method. So let me do together. X minus 2y plus 3z equal to 1. 3x, no, sorry, x plus 2y minus z equal to 13. You can see from the equation number 1 and number 2, which one is easiest to remove? 2y. So y is ready, right? So I'll get what? 2x, okay. Now you understand what I mean by equation number 4, right? But careful, equation number 4 contains which variables? So if I add or I subtract equation number 1 with the 3, I should remove y. Understood? You got it? Good. Yalla. Equation number 1. Let me change the color. Let that one be pink for the girls. That time 2 minus 2y, 3z equal to 1. That's the first equation. Am I right? Do not forget about equation number 4. We are keep it with a 5. So here's the equation number 3. 3x plus 2y. Okay. Minus 5z to 0 to 3. Okay. Good. Now I'm going to add or subtract. Up to you. Maybe here y is not ready to eliminate. So make it to be ready by multiplying, by anything that you like. It should be x and z alone. So I'm going to add them again. 4x, 2z, 4. Am I right? So what's the name of that one? Equation number 5. Thank you. So now I have equation number 5. And I'm going to bring equation number 4 to x to z equal to 14. Then now I am in the 10.1, right? I have system of 2 variables, 2 equations. So we are in a 10.1. Clear, dears? Good. Now how we deal with that one? You can cancel it as you say. So 6x, 20, right? 18, sorry. Good. As 18. So x is equal to what? 3. Now is easy. So I should put where? In which equation? 4 or 5. Yes, we should put it in 4 or 5 because we have an x and z there. So let be 4. I'll get what? 2x plus 2z equal to 14. Am I right? Good. So 6 2z equal to 14. You can divide by 2. Up to you. So x, z will be what? 4. Now I have x and z. So put in where? You can say 1, 2, 3. Up to you. Here you can say 4 and 5 or 5. Here you can say put in equation 1 or 2 or 3, whatever you like. So I have a, let me see the equation number 1. X minus 2y plus 3z equal to 1. Yes. And I know z is equal to 4. And I know y is not anything. And x is 3. So 3 by 4, 12 plus 3, 15 minus 1, 14 by minus, right? And we have 2y. So, sorry? Yeah, y is equal to 7. So the solution, and understood here? It wasn't hard, but actually it needs time to just make a difference. Clear? Yalla, can you solve that one for me? Yalla, day. Let me use the PDF. Yalla. Repose the video. Here, look at here. In this example, we are going to, well, let me solve it on the lecture, not actually, not here. So you can see from here, we are going to together to solve the example number, equation number 1 and the number 2. So I'll get that equation. That's called equation number 4. After solving equation number 1 and 3, I'll get equation number 5. So here's your 4 and here's the 5. So when you see that when they are together, they look like each other, especially the left side of my equation, 100% like, but here's the difference. If you try to solve, of course you should solve that one. If you try to solve, I'm going to make multiplied by what? By minus, for example, here, right? So I'll get what? I'll get 2 equal to 0 or minus 2 equal to 0. When you get that one in 10.1, we say what? No solution. Understood? So if you have a solution, Kaka, guys, if you have a solution, it means that you did a mistake. If you don't have a solution, you stuck here, means that you are right. So the system has no solution, even it's a 3 by 3. So I'm going to the next example. Yalla, quick with me. Don't solve it, just help me. So I'm going to multiply that one by 2. Am I right? Yes. I just multiplied by 2. So then I'm going to make it by minus. Am I right? So if I change with that one to equation number 1 and equation number 2, if I am going to add them, of course that one will be 0. 3y, 10 plus 4 minus 6z equal to what? 6. That one will be my equation number 4. Do you have a question? I know I'm fast, but you don't need to think about it. I'm going to use the that one together. Look, I told you, you are free. You can use 1 and 2, 1 and 3, or 1 and 2, 2 and 3. Up to you. So I'm going to use the 2 and 3, okay? Understood? Up to you. At home, try to use 1 and 3. So I'm going to just multiply this one by minus, by minus, by minus, by minus. I'm going to add them. 3y, 6z, 6. So I got what? 3y, 60, number 5. So when you saw that, so yes. Why? Because left and right, they are equal. If you don't know, just multiply that one by minus. You get 0 equal to 0. So in that case, you see infinite solution. Understood? Clear. Now I'm going to the last example. You can see from here, you get that one. So it means that you have a... So we finished. So kindly, the last example that I'm going to solve it with you, we are going to the exercise number 17. When I say, and some students told me where's the questions. When I say go to the exercise number 17, so directly you are going to the end of the section. We are going to solve 17. It was 7 or 17? 17. Okay. So kindly solve that one at home. But as a first exercise, we are doing at here. Okay? Yalla, can you solve that one? It's easy. And it will be the last of the class. The end of the class, okay? Happy, right? I can see. Yalla, solve that one, and I'm reading your name, calling your name.